Hello everybody, thanks for joining me. I just wanted to make a kind of a quick follow-up video. We had the opportunity a couple weeks ago to attend the expo at the Bassmaster Classic in Tulsa, which was a great experience, and we got a ton of positive feedback from a number of people. I think the product is it's creating a lot of buzz. I've gotten several hundred emails since I've gotten back, and with that we've gotten a lot of questions, and instead of trying just to head off all of them, I thought it'd be a good idea to set up and do a series of videos and address some of those questions in the videos. So anyway, one of the things that's come up is a YouTuber that I really have a ton of respect for reached out to me and was asking about the product, and he made the comment that he thought that the foot control looked fragile. And so I kind of wanted to go. I went through it with him and told him about how it was made, and he said I should shoot a video about it, and that's one of the big reasons why we're here. So with that, I want to go through and break down the construction elements of our foot control, and this will be good for the people that saw it at the show got a feel for it, but the people that weren't there might look at it and think that it's something that it's not. So anyway, let's jump in. The main element of the foot control is certainly the frame, and here's a frame that's straight out of the milling machine, that shows how much material we moved, how much detail is involved in that frame, this starts life as this. So we start out with a billet block, 6 by 8 inch billet block of aluminum. This weighs almost 5 pounds, and we remove all but 1 pound of that. So we're at over 80% material removal on this part. You'll notice it's still very, very sturdy. It's the thickness of the material around the edges is the load-bearing part, and there's very little chance that you could bend this even if you tried to. One of the main elements of the foot control that I wanted when I started out to design it is I wanted it to be very thin. I didn't want you to have to stand up and have your foot above, the deck of the boat several inches like you do on your trolling motor. I wanted it to be very, very low profile so that you could keep your weight on your foot. And so with that design goal, we had to really focus on our packaging, and I think we pulled that off. So the frame is certainly the main element. The next element to talk about is the polycarbonate cover, and obviously this is clear, and it's clear so that we can see the LEDs. It's also not metal, so that we can get signal in and out of here. It's not a Faraday cage. The CPU that we're using is Bluetooth and wireless, which down the road is going to come in handy. But this clear lid is made from a solid block of polycarbonate. And this is 1/2 inch thick, UV resistant Tuff-Ak, which is a brand name polycarbonate, leader in the industry. And this is what bulletproof glass is made out of. If you go to a convenience store and they've got a big panel, it's probably this, except it's about half this thick. So this is unbelievably tough plastic, and can carry an amazing amount of load. I mean, it just does not flex or bend, and it's crazy, crazy tough. So we start out with this. We put this in our milling machine, and this is what comes out. So this is a finished cover, and we machine a little recess in there for the rubber inserts. These rubber inserts are EPDM rubber. This is shoe sole rubber, and this rubber is amazingly tough. We played around with EVA foams like you see on a lot of bass boats. I didn't like the thickness that they added, and I didn't like the durability of them. So we circled back to this, and we cut this ourselves out of big sheets, and we're super happy with it. I mean, it's UV resistant, water resistant, and I have been unable to tear it as much as I've tried. And they're stuck down with 3M double-sided adhesive. It's the same adhesive that most car emblems are held down with. So moving on from the foot control, from the lid, under the lid. So we'll go back into the body here. Under the lid, we have a bearing. So you may recall that I said one of the main design goals was for this to be really thin. I also wanted it to be really free spinning. I wanted it to move, and you can see it has almost no resistance at all to it. And that's on purpose. I wanted you to be able to flick this thing with your toe, so you can make really quick movements, and then also move it 1 degree if you want to. But I wanted this to be a really, really free moving thing. So we set out to find a bearing for these lids to run on, and we couldn't find one, so we ended up having to make one. So this ring is made out of acetyl plastic, which is commonly known as Delrin, and it's a plastic sheet, and we mill this in our milling machine, and we machine out the profile, and then we drill the holes through it, and then I take a little ball end, it's called a lollipop end mill, and make a pocket for the ball bearings to retain them. So the walls of that are not shaped like this, they're shaped like this. And it allows us to pop these stainless steel ball bearings in and out, which the ball bearings are precision ball bearings, 3/16 inch diameter. They're made in Chattanooga, Tennessee, and they're made from 440 stainless steel, and they each will support, I believe it's 500 pounds. So you can do the math on that, and you can see that we've got plenty of load capacity for whatever wants to stand on it. But this lid just falls right in on top of that bearing, and it gives us the free movement that we need. So another big aspect of this assembly, if you'll notice, there's a groove. Let's see if I can get this on camera. There's a groove that runs around this foot control, the lid. And that groove is super duper important. The way we retain this lid sits on top of, this is an older circuit board, but this magnet that's in the center of this lid runs on top of a chip that rides right here. And that's what allows us to get our indication on the direction that this is pointing. And it gives it to us to 1/100th of a degree. Very accurate setup. But one of the challenges, since it's in the middle, we could not create a spindle for this to ride on. So we had to ride around the edges, which works fine, but we had the challenge of how do we retain this in the frame. Because I didn't want this to fall out. So this is all retained. So the solution to that was we use a washer that rides inside of these slots. You'll see the 4 slots that are around the frame. And there's a washer. This one has a washer in it right here. And that washer rides on a screw that comes in from the bottom of the frame. And that screw is shaped like this. And you'll notice it's got a machine part on the top, but the machining of that is all center. And that off-center portion runs up through here through this washer, and it allows us, when we turn this, hopefully you can see it here, it extends that washer into that slot. So a half a turn will go from all the way open to all the way closed and extend that washer out into into this groove that runs around radially around the lid. The beauty of this system is, number one, it adds no friction to the spinning. So it's totally free because these spin. Number two, it's user serviceable. So the way this is going to work, on the underside of the lid, you're going to see it's going to be laser engraved with an open and a line on all these screws. And all you'll have to do is turn that to where those line up. So when they line up, you'll do that for each one. Then the lid will just come right out. And we want it to be that way. We look at this, we think of this as a reel. Reel manufacturers don't lock them up so that you can't get into them. A reel manufacturer assumes that from time to time, you'll open them up, you'll clean them out. If the bearing ends up getting something on it, you can just open it up, clean it out, stick it back together, pop it back together, flip it over, turn those screws, and reassemble it. And you can do that in about a minute. So if moisture gets in it, or if something did get in it, it's very easy to take care of. And that's a very common question we get. Which, one of the ways this thing is set up, you'll notice it has a stair step around this edge. Okay, and that is what's called a labyrinth seal. So for any debris to get in it, it's got to go in, up, over, and down. And then once it goes down, we've got channels to channel it away from the bearing and the circuit board. So even if it does get in, we're hoping to keep it off the circuit board. And if it does get on the circuit board, it's okay because it's coated. If it gets on the bearing and it starts dragging, you can just open it up, clean it out, and it'll be just back to new. So we've tried to make every aspect of this very, very serviceable for the end user, and it's very easy to do. So anyway, so that's a little bit about how the lid works. Now moving on, one of the things I wanted, you'll notice how thin the pedal is. I wanted it to be less than an inch thick, and that's how thick the running surface is. So this is very thin. When you're sitting there using it, you can still have all your weight placed on the heel of your foot and your toes just barely off the ground. In addition to that, I wanted the buttons to be very low. So to get the buttons the height we wanted and to get the feel on them that we wanted was a challenge. I wanted the feel on it to be much like a mouse. And a mouse has very little pre-travel and very little after-travel. And that was kind of the feel that I was going after. And we went through, I'm guessing, 100 different buttons trying to find the right button. And the button needed to be waterproof, it needed to be very durable, and it needed to be very short. So that eliminated almost all of them. So we came down to a few. A couple of them were cheap, and then we found this one. And this button is, let's see if I can get a picture of it. This button is made by Otto in Illinois, and it is a mil-spec button. And this is all machined aluminum with machined aluminum threads. It's all sealed. It is IP68, so it's a submersible button. And talking to my rep at Otto, these are used on almost every aircraft our military has. And this particular one is used in the fire control on a F-22 fighter jet. So they are very pricey. I'm glad I don't pay the price that the military pays. But these two buttons that ride in here are more expensive than the rest of this whole foot control. They cost me more than the rest of all this together. So that tells you how nice these buttons are. You can see from this shot, they thread in from below. So we thread them in, they protrude through the top, and the buttons just ride right on top of that. And it gives very nice, very short travel in a very positive click action. So we have a stainless steel spring that we source from a Kentucky vendor, and then these are retained. To get this as low profile as we needed to, this could not have a hinge. So this is just on a pivot. So this is just on a little pivot, which is the way a mouse works, computer mouse. So it gets really low profile, really short movement. So we're really happy with the way that turned out. Again, the buttons, our buttons start life as this is a block of aluminum. That's a block for the button, and we machine it down to that. So it's all billet, and very durable. And the covers for this, again, are the EPDM rubber inserts with a 3M adhesive, and it gives us really a nice texture on the button. So the last piece of this, the wiring that we use, the connector is an M12 connector. A NEMA connector is also an M12 connector, but this is a data grade M12 connector, and it's 8 pins, and it's got a metal housing. And you can, I don't know if you can see here, but if you can see down here, the wires are all epoxied into these. So this part of it out here is sealed IP67. This part is IP68. These are Molex connectors that we put together, and these are all silicone coated when we put the boards together. It's very low profile. We have 2 screw holes that we can screw it down to the front deck of your boat. You can also run it just free. One issue is it's so smooth on the bottom that it does slide around. We put some rubber feet on the bottom of some of them, and that's kept it from moving around. But anyway, so that's the foot control, and again, I'm gonna do a series of videos going over the physical parts of this. We're gonna jump in. The next video will be on the actual motor housing and those parts, which have a lot of neat little things to it, neat little details. And after that, we're gonna go back through and do another how-to video and show not only how to install it, but we're gonna show how to go through all the different functions and what they are. Because the videos that we posted last year are definitely outdated. We've added some new features, and including controller motor sync, which is fantastic. And we've made the menu system a little easier to navigate. So we're excited to get those out to you. So stay tuned for that. Appreciate you watching this, and look forward to getting more content out there. Thanks.